Okay, so we are going to do section 7.1, exponential functions and their graphs. And we'll just get started with an exponential function and we'll talk about how to graph it. So if I'm given g of x equals 5 halves, and this is raised to the x power. Okay, well, from our notes, we have to realize, hey, the a value in this problem is a 5 half, 5 over 2, 5 halves. And in this case, we know that 5 halves is greater than 1. So because of that, we know that this particular picture of our function is increasing. So it's going to look something like this. We also know that the y-intercept is 0, 1. Now, we could make an x and y chart, and we could pick some points, and we could graph it really nicely. However, in Hawks, all that you really need to know is where the new where the one specific point is. In this case, the y-intercept. And so what's going to happen is in Hawks, they're going to give you a bunch of different graphs. Okay, some might look like this. Maybe one looks like this. I don't know. Basically, what you're going to have to do is pick from them. Okay, and so I'm going to show you how to do it with just a little bit of effort. And so what we'll do is we'll plot the point 0, 1. And we know in our mind that it should be an increasing function. It should look like this. And so really all I'm going to do is draw my line, and there I have it. And so what happens is the most important part of this particular graph is this point. So you're going to look in Hawks, and you're going to find the graph that resembles this guy, and you're going to click it, and then you're going to be done. All right, so the second one, basically, we're going to be doing these all the same pretty much. We're going to be given that f of x equals 1/4 to the x, and we're going to say, okay, well, in this case, a equals 1/4, and I know that 1/4 is less than 1, and so this is going to be a decreasing function, and so it's going to have to look something like that. And again, we know, since nothing else is happening to my function, that the y-intercept is just 0, 1. And so I can just graph this thing. I can plot my point 0, 1, and I will make a decreasing function this time. And again, in this particular problem, the most important thing is this point. And so you're going to look through the Hawks graphs, and you're going to find the graph that resembles this guy, and now you're done. Okay, so those first two that we had, nothing else was happening to them, so to speak. They were strictly increasing or decreasing. Well, let's take a look at the third one. If I have p of x, that equals 1/3 to the negative x. Okay, so we know again that our a is 1/3, and we know 1/3 is less than 1. So this is a decreasing function, which means it's going to have to look something like this. And we also know that its y-intercept is still, oops, hold on, let me fix that, is still just 0, 1. Now, here's the thing. This little guy right here tells me something. Because of the negative sign in front of the x, we learned this in the last section, this is going to be a y-axis reflection. And if we remember, the y-axis is this guy. And so we're going to have something, and we're going to, maybe it's over here, we're going to flip it to the other side. That's what y-axis means, y-axis reflection. So here's what we're going to do. We're going to say, okay, well, generally speaking, here's what our graph would look like if no reflection was happening, okay? But since we have a y-axis reflection, we know that it's going to be reflecting over this particular line. Well, since it's not moving left, right, up, or down, this point is going to stay the same. My y-intercept is going to stay the same. And what's going to happen is instead of it decreasing, it's literally just going to flip around. It's going to reflect over this line. And so all the points that are over here are now going to be over here. And so when I do that, it's going to look like this instead. And so it's kind of like, I don't even need these black points unless you like them. And the green line is going to be my final answer. So my intercept stayed the same. I reflected this thing over the y-axis, and I'm going to look in Hawks, and I'm going to find the graph that resembles this, and then I'm going to be done. All right, number 4. F of x equals 15/4 to the x minus 2. So in this case, we start out the same way. We say that, we say that a equals 15/4. And in this case, we know that's a number that's actually greater than 1. So this is an increasing function. So it looks something like that. The y-intercept is going to start out at 0, 1. And so here's what's happening to this guy. When I see this 2 right here, this is going to tell me that I'm going right, oh my goodness, I can't spell, right 2. And so what's going to happen is I'm going to have my graph, and since I know that this is generally an increasing function, it would look like this. And since I'm going to pick this thing up and I'm going to move it right to, that's literally what I'm going to do. So I'm going to pick up this black dot, or this, this y-intercept. I'm going to scooch it right to. And since nothing else is happening, then I can draw my line. And again, you can to actually take out this black dotted line. That's just for our reference. And we can say, okay, the blue line is going to be my final answer. And my y-intercept has scooched over a bit, so to speak. It's not the y-intercept anymore, but the point now is 2, 1. Okay. Number 5. Let's see, number 5. All right, we're going to have q of x equals 13/4 to the negative x. Okay, and so we know that a equals 13/4, and I know that that is greater than 1, so this is an increasing function, going to look like this. The y-intercept is 0, 1. Now again, we've seen something similar to this. This guy right here, this tells me that there is a y-axis reflection. And so nothing else is happening. It's only being reflected over the y-axis. And so in black, this is what my function would look like if there were no reflection. But since there is a reflection, a y-axis reflection, here's my y-axis. And since nothing else is happening to this particular problem, all the points that are on the right-hand side are going to come over here to the left-hand side. And now my new function is going to be this in the green. And so again, I'm looking for the graph in HAWX that resembles this, the green line, not the black line, and now I'm done. All right, now I want to do one more, and this next one's going to be a bit of a doozy because it's going to have several issues that we're going to have to take care of. So let's take a look at this one, number 6. So we have f of x equals 4 plus 2/3 1 minus x. Okay, now this looks bad right from the get-go. Okay, there's a lot of things. We haven't seen our front-running number, so to speak. We haven't seen our x value being behind. Typically, it's out front. So what we're going to do is we're going to rewrite this whole problem because I don't like the way this looks. So we're going to say, you know what? I know that I'm allowed to just move pieces of the problem as long as they keep their actual value. So I'm going to bring the 2/3 out front. Okay, that's taking care of this guy. Now, I'm not used to seeing something that looks like this. What if I go ahead and put the x first? Well, the x is negative. The 1 is positive. Hey, that looks like something that I'm more familiar with. Okay, so this is taken care of. And then this is a positive 4, so plus a big 4. Okay, and so we'll say that a is 2/3, which is less than 1, so it's a decreasing function, so it's going to look something like this. The y-intercept is 0, 1. And then I see several things happening. Okay, so let me get some different colors going. The first thing that I notice that's happening is this plus 1 tells me to go left 1. And then the next thing that I see happening is this, and that negative x tells me that there is a y-axis reflection. And then the last thing that I see happening is this big old plus 4. And this big plus 4 tells me to go up 4. And so here's what we're going to do. We're going to start over here with our graph. And we're going to graph our black function first, just to show you what it would look like. So let me get some tick marks made out here so we can have a better idea of exactly where this is happening. So 0, 1, that's this point, and we said it would be a decreasing function, so it would be coming down, something like that. Okay, but we have 3 things that's happening, okay? Excuse me. We have 3 things that are happening. And so the first thing that's happening in red is I'm going to move this thing left 1. Well, when I move this left 1, if I start at the point 0, 1 and I go left 1, then I've gone to negative 1, 1. And so if all I had to do was go left 1, then my graph would look something like this, right? Not a huge change. Okay, well, that's not the only thing I have to do. The green negative sign is going to tell me that it is an x-axis reflection. So I'm at the point negative 1, 1, because that's where my new, I don't want to call it a vertex, but that's where my new, I don't know, that's where my new point is, okay? And so I'm messing around with this point. I'm changing it. And so if I start at negative 1, 1, this y-axis reflection, remember, here's the y-axis, tells me I'm going to pick this guy up and I'm going to scooch it over here. I'm mirroring it. And so that's going to be the point positive 1, 1. Okay? And so now if I'm at the point positive 1, 1, whoops, let me get this done in purple. if I'm at the point positive 1, 1, and I'm going up 4, well, that means I'm going to add 4 to my y value, so I'm going to be at the point 1, 5. So what's going to happen is I'm going to come over here to 1, I'm going to scooch up 5, 1, 2, 3, 4, 5. And so this is going to be the new point through which I draw my line. And now I have to decide if it's going to be increasing or decreasing, okay, based on, the changes that happen. Well, if it was decreasing initially, okay, and when I flop this thing over on my green, in the green step, this was my new point, and it was going to be looking something like this. And so what's going to happen is this particular line that I'm actually about to draw is now going to be an increasing function. And even though we did all of that work, this little guy right here is my actual final answer. So you're going to find a graph somewhere in Hawks that looks something like this. And this is it. We're done. So when you have a problem that is written backward, just fix it, and then list out your steps, and then make those changes. And so now we're done graphing. Now, the other type of problem that we saw in this section was when we had to solve some equations that had really nasty looking exponents. And so let's go ahead and let's take a look then. Number 7. And this is going to be where we have to follow our steps. We have to get our exponent by itself and all that. So let's take a look at this. So let's say that I'm given the number 27 to the x minus 2, and that equals 9 to the negative x plus 3. Okay, our goal here is to get these two bases to be the same number so that we can get rid of them and set the exponents equal to each other. And so we have to ask ourselves, okay, we need a number that's raised up somehow and gives me 27. And then I need that same number to be raised up somehow to give me 9. So for this problem, we're going to say, well, 3 to the third is 27. So I can rewrite 27 as 3 to the third, and then it's still being raised to the x minus 2. On the other hand, I know that 9 is just 3 squared, but that's still being raised to the negative x plus 3. And so now what's happening is these bases are exactly the same. And so then I get to take the exponents, which is all of this, and set them equal to each other. However, before I do that, I need to remember, way back when we talked about exponents, when we have two exponents that are being raised side by side, we have to multiply. So this 3 has to be multiplied by the x and the negative 2. So I'm going to write it out like this so you can see it. Same thing with this 2. And since our bases are the same, we don't really care about them anymore. Okay, that's not what we need. And so here's my problem. And so I'm going to go ahead and I'm going to solve this just as if it were a normal equation. So I'm going to get 3x minus 6 equals negative 2x plus 6. And then I'm just solving this normally. So I will add 2x to both sides, and I will get 5x minus 6 equals 6. And then I add 6 to both sides, and I'll get 5x equals 12. Divide both sides by 5. X is 12/5. Done. That's it. All right, next. Number 8, same type of a problem really. 32 to the x minus 64 equals 0. Well, the first thing that we always have to do is make sure that the exponent is by itself. So I'm going to add 64 to both sides. And so that's going to give me 32 to the x equals a positive 64. Okay, and so again, you're probably going to need your calculator until you get used to these types of problems. But I need some number raised up to give me 32, and that same number raised up to give me 64. Well, it just so happens that 2 to the 5th gives me 32. Now it's still being raised to the x. And that also 2 to the 6th gives me 64. And so now that my bases are the same, I don't care about them. And so I'm able to say that 5x equals 6. And in this problem, way fewer steps, x is going to equal 6/5. Done. All right, number 9. 32, so this one looks similar to one we just did. 32 to the negative x equals 64. So from the previous problem, we already know that 2 to the 5th is equal to 32, and we already know that 2 to the 6th is equal to 64. And so in this case, I'm going to have 5 times negative x equals 6. Well, that gives me negative 5x equals 6. Divide by negative 5, divide by negative 5, and x equals negative 6/5. All right, this next one, number 10, is going to look a little different. It's going to have a fraction. So we have 7 to the 5x minus 1 equals 1 over 49. All right, so we don't really want fractions. So we're going to take a side note over here, and we're going to have to deal with this. Well, we've learned from way back when we talked about exponents in the beginning that typically if I have a if I have a fraction, I can turn it into a number by doing something with a negative number. Okay, so I'm going to rewrite this as 1 over 7 squared. Well, because 49 is 7 squared. I need this to get out of the bottom. And we had said earlier, if we want to, we have to flip this, right? Remember back to our bookshelf? In order for me to flip this, this is actually going to become 7 to the negative 2. Because if all I had was 7 to the negative 2 to start with, you would say, oh, that's 1 over 7 squared. And oh, hey, that's 1 over 49. And so what's going to happen is 7 to the 5x minus 1 is going to stay the same. And 1 over 49 is going to turn into 7 to the negative 2. Okay, well, my bases are the same. And so now I literally just say that 5x minus 1 equals negative 2. And I solve it like normal. So I add 1 to both sides. And I'll get 5x equals negative 1. And then I will divide. And I will get x equals negative 1/5. And now I'm done. All right, number 11. 125 to the negative x equals 5. Well, in this particular problem, this guy over here is already the base that we want because we can't break 5 down any further. And so this is going to just stay 5. We need to somehow turn 125 into 5 to the something. Well, again, maybe through calculator work, whichever you need, we're going to determine that 5 to the third is that is that 125. And it's still being raised to the negative x. Okay, so our bases are the same. I take 3 times negative x. Now over here, we mentioned this before. Anytime you just have a whole number, it's raised to the first power. And so this is going to become negative 3x equals 1. And I'm going to divide both sides by negative 3. And I'm going to get that x equals negative 1/3. Now I'm done. All right, now this next one, number 12, is going to have some fractions, and it's going to look bad, okay, but I'm going to show you that it's not that bad. So we're going to have 2/3 to the 3x plus 4, and that is going to equal 8 over 27 to the 5th. Okay, now, typically, the bases that we want are smaller numbers, like 2, 3, 5, things like that. Well, as it just so happens on the left-hand side, 2 and 3, we can't break those down anymore. So our goal is to look over here at this fraction and say, is there any way that we can take these numbers, 8 and 27, and turn them into a 2 or a 3? And it turns out that we can. And so what's going to happen is we know that 2 to the third equals 8, and we also know that 3 to the third equals 27. And look, right here's our fraction. And so what's going to happen, we're going to leave 2/3 to the 3x plus 4 alone, and we're going to say, all right, 8/27 is actually 2/3 to the third power. But here's the thing, it's also being still raised to the 5th. Okay? And so again, this side over here will stay the same, 3x plus 4. When we have two powers, power to a power, we have to multiply. And so that's going to give me 2 equals 2/3 to the 15th. And hey, guess what? Our fractions are the base. And since they're equivalent, we can just say 3x plus 4 equals 15. And then I just minus 4, and I get 3x equals 11. And then I divide, and I get x is 11/3. And now I'm done. Okay, next, number 13. We will have 32 to the x minus 2 equals 0. Well, again, the first thing we need to do is get our x value, the exponent value by itself, rather. So that's going to give me 32 to the x equals positive 2. And then again, from previous problems, we already know that 2 to the 5th is what gives me 32. This is just the number 2. Remember, when it's just a number, it is just raised to the first power. I take these two exponents, I multiply them together, and I say, okay, 5x is equal to 1. I divide both sides by 5. I get x is 1/5, and now I'm done. All right, just a few more. Number 14. I have the number 1,000 raised to the negative x equals 10 to the 2x minus 12. All right, well, 10 is a good base. I can't break it down any further, so I need to somehow figure out how to turn the number 10 into 1,000. Well, turns out that that is 10 to the third, but that's still being raised to the negative x. I didn't mess with these guys, so I leave them alone. Well, I have the same bases now, and I can say, oh, hey, look. So 3 times negative x equals 2x minus 12. Well, that just gives me negative 3x equals 2x minus 12. I minus 2x from both sides. I get negative 5x equals negative 12. I divide both sides by -5, and that's going to give me x equals 12 fifths. And now I'm done. All right, two more. Number 15. 2 to the 3x minus 7 equals 1/4. So again, 1/4, we need to somehow figure out to turn it into an actual number. Over here, this guy, the base 2, he's not going to change. So 2 to the 3x minus 7 is going to stay the same. I need to figure out how to turn this 4 into base 2. Well, as it would turn out, 4 is just 2 squared. And like we talked about in a previous problem, we need to get this 2 on the top, so to speak. And so we're going to say, oh, this is actually 2 to the negative 2. And then we can always check ourselves, because we know from previous lessons we can't have negative exponents. So if all we had was this guy right here, we could say, oh, well, that's going to have to be 1 over 2 squared. Well, oh, hey, I know what 2 squared is, 4. And so we're going to replace the number 1/4 with 2 to the negative 2. And so now my bases are the same, and I get to say that 3x minus 7 equals negative 2. And then I just solve like normal. And so I'm going to get 3x equals 5. And I'll divide both sides by 3, and I will get x equals 5/3. And now I'm done. All right, I want to do one more with fractions just to make sure that you have a pretty good understanding. So we're going to have 1/3 to the 5x plus 1 equals 1/9 to the 6th. And again, the number 3 and the number 1, they're already broken down as far as they can. There's nothing I can do with those guys, so they're going to have to stay. And so what's going to have to happen is I'm going to have to try to somehow turn the number 1/9 into 1/3. Okay, well, the cool thing about the number 1 is if I square it, I still get 1. If I cube it, I still get 1. And so really, 1 is just 1 squared. Okay, well, how can I turn 9 into base 3? Well, isn't that just 3 squared? Sure. So the number 1/9 is actually the number 1/3 squared. And so I get to come back over here and I get to say, okay, well, that's squared. It's 1/3 squared, but I can't forget about this guy. So again, on my left-hand side, 1/3 to the 5x plus 1 is going to stay the same. When I have a power to a power, I have to multiply. So this is going to give me 1/3 to the 12th. And now my bases are the same, and all I have to do is say, hey, 5x plus 1 equals 12. And I'll minus 1, and I'll get 5x equals 11. And then I will divide both sides by 5, and I will get x equals 11 fifths. And now I'm done.